All right, guys, so we have exponential growth now. So these are all going to be growth equations. So looking at it, y equals c 1 plus r to the t. Big thing is rate of change as a decimal. All right, that might show up as a percent. And so you guys got to know 50% as a decimal. We would move our thing 1, 2. And so 50% is 0.5. One way to think of it is 100%. 1, 2 is equal to 1.0. And so think about for your percents and moving the decimals and making sure you can keep it straight. So write each percent as a decimal. 1, 2. This is 0.124%. Maybe you need to keep this slides or these out so that you can see it. Because 1, 2 means I need to fill in a 0 there, so 0.06. 1, 2, fill in a 0, 007. All right, little James Bond action. So here's what we got. You have C 1 plus R to the T was the equation we gave you. Good news. These graphs always start at -1, 1, 2, 3, 4. So we talked about that earlier. This is going to be 8, 1 plus 0.45, and then this is x now as our variable. So this is going to be 8 times 1.45 to the x. And so I would just let the calculator do the work for you. I know there's an equation row there, but here's our equation right here. So I would do 1.45 to the negative first power. And if I need to show you how to do that in a calculator, I can do that. But ultimately, you get around 5.5. All right. Anything to the 0 power is 1. So it'd be 1 times 8 or just 8. 1.45 times 8 is 11.6. All right. And then we'd probably have 1.45 to the second power times 8 is around 16.8. 1.45 to the third power times 8, about 24.4. I'm going to stop there because now I'm off the graph. So -1 is 5.5. This is 0.8. This is 11.6. So just across there, 16.8. Just across there. 3 is 24 up here. All right, and you can see how fast that's going to grow with an exponential growth equation. Backwards, this number is 1.45. Try another one. All right, first things first, and I'd see this. I want to make sure I don't screw this up. So I'm going to write 0.134 as our rate. All right, so then our C is 6. We're adding because it's a growth equation. And we have x now. So y equals 6 times 1.134 to the x. Once again, we're starting at -1, 0, 1, 2, 3, 4, as far as we need to go. So I truthfully you just have to know how to use a calculator. All right? And so we can show you how to plug it in. Most of you have a caret key, so this should be about 5.3. Okay, this should be about 6. Now, the reason you guys should be practicing on a calculator right now is because you're not going to be able to, ask questions during the ACT and different things like that. So we just got to get you as skilled as we can before we take that. About 7.7, 1.134 to the third times 6 is around 8.7. 1.134 to the fourth times 6 is about 9.9. I'll even do 5 here. 1.134 to the fifth times 6 is about 11.3. So -1, 5.3 approximately, 0.6. 2 is, 1 is 6.8, 2 is 7.7, 3 is 8.7, 4 is almost 10, and 5 is 11.3. So you can tell it's slowly getting that curve up. Probably not as fast as the other one. And actually, this number is 1.134. I just scribbled under them. This one is a little bit smaller, so it has less. The other one was 1.43, I think. This one's going to go up faster because it's got a greater increase, or it's a greater value. Something to think about when you're measuring how much growth there is. Right? There were this number of many females in high school sports. Since then, the number has increased at a rate of 8.5%. So, first things first, 1, 2, 0, 8, 5. So notice I had to add a 0 on that one. I think you have to know that our starting value is at 290,000, whatever that is. Then we're going to have 1 plus 0.085, and then usually we just use x. And even, I'm not even going to write the 1 plus. So it's really nice because whatever the 1 is, and you add it, it's just going to be 1 plus that. So it works out to be just 1.085 since 1971. Okay? According to the equation that you wrote, how many females participated in 2005? I would tell you the cheat code is to take 2005 and just minus 1971. That tells you the number of years. And so we should have 34. So this is 34. So what I would probably do is just to go 294, 105, 1.085 to the 34th. All right, so 1.085 to the 34th power times 294,105. Right, and so you just have to know that you get 4,711,004. Now I rounded this one to a whole number because people are wholes. We don't have half a person here. So just make sure you think about that too when you're rounding. Right, so you can tell how much sports have increased for females. Apparently the slide's on here twice. I'm skipping it. In 2010, the city of Farmington had a population of 21,000, growth of 0.19. So if I move that decimal, 0.019, I would tell you I'm pretty confident this is my starting value, so my C. I'm going to add this, so it's 0.19 to the X. Once again, we got an easy number with 2010 up here. So what I would do to solve this is I would do y equals 21,087, 1.019, and I would trade this to a 3 for 2013, and then for 2017, I would just write the same equation, but 2017 minus 2010 is going to give you 7. So I'm just finding two values here. So 1.019 to the third power. And then I just times it by 21,087. I get 22,312. And then when I think about it again, 1.019 to the seventh times 21,087. This number is going to be 24,057. So slowly but surely we're increasing the number of people here. All right, the DNR has been tracking the deer population since 1970. I'm going to go 1970 because this is down here. Okay. At that time, the deer population was 500 and has been increasing at a rate of 5. So like I already was thinking 0.05 because 1, 2, I got to add a 0. All right, so we started with y equals, we started with 500 deer, 1.085 point, and we're going to add the 0.05 to the x. So 2017 minus 1970, that should be 47. So what is the expected deer population? I'll do 1.05 to the 47th power. All right, and 1.05 to the 47th is a number around 10. I multiply by 500, and we're going to know that there were now 4,953 deer for the expected population in 2017. All right, that one gets a little long-winded, but hopefully you were able to do the calculations in your calculator and understand all of these were growth problems, and we're just adding to the one in the middle. Thanks for listening.